It all sounds very different, right? So is a porter required? Sorry? Is a Pro5 porter required to write such a code? And the answer is no. And one case no. It's all just pattern recognition, right? Because Perl generates pretty predictable object stuff. It's always the same. If it's x multiplied by y, it will be this part of the code. If it's z multiplied by a, it will be the same object with different variables. It's same story over and over and over again. So we just need to figure out whether we're talking about female monkey or we're talking about the one, which is going to be this. And of course we need to detect minor variations. Because if you are dealing with our variable, then it's one. And if you're dealing with my variable, it will be a slightly different option. So minor variations are important. For example, our and mine. Otherwise, subs which do nothing really, they just return variables. So we could see the pattern here. We still have the subroutine entry point. We still have a sequence of the statements within the subroutine. We still have the line number somewhere, and the return statement. And the push mark is always there just for it. Not interesting. Because, I mean, of course it's an important opcode in the Perl context, right? The push mark, whatever it does, something clever, I'm sure, but we don't care. Right. So basically the only difference is what it is we are going to return. And this was our variable. And then there's this funny unary operation called null, which basically means that it was something else, but Perl decided that it doesn't need it and optimized it away. And was basically too lazy to try and actually remove it. It just replaced the actual operation with null. And then, well, I mean, this is just the GB, right? Which is a global variable, and it has a name. And here, it's a PADSV, and you already know that PADSV is a library. So basically, when you would like to hijack Perl syntax, then you write that syntax you are going to hijack. You feed it through the deconcise. You see what it does, then you code. So, again, two very simple subroutines. Minor differences in the pattern recognition here. They're precisely identical to each other, apart from the name of the spider operation. In the first case, we were adding two variables. In the second case, we subtracting one. So, deconcise is all well and good, but what if you actually parse it not with your eyes, but within your program? Then we need something else. And here, basically, you are going to be using the B module, which is a part of this Perl compiler suite. And we had a nice talk about the compiler suite yesterday. But again, we don't need anything fancy. We are not going to generate C code or whatever. It's very simple. And what B module does is basically it provides you almost direct access to all or most Perl internal data structures. For example, a function within the B module called SV reference, which is a scalar value reference to object. And basically, they mean object as in B module object. So the scalar value reference is the real Perl stuff, and the object is its shadow in the B module. So, if we execute it, we can see that basically most of the stuff we might be interested in is represented basically by the B module. So we have an object of a class B ID, which which stands for integer value, and NV, which stands for numeric value, and PV, which is the pointer value of the string, and so on and so on and so on. Arrays, hash values, and most interestingly for us at the moment, code values, which is another sub. So, a very, very simple subroutine which just returns true, even without a return statement as such, right? So, just 4 opcodes. The entry point, the signals, because every subroutine is a sequence of operators. The debugging thing gives a line number, and basically the operation which says, okay, I am a constant number integer 2. How would we parse such a subroutine ourselves using the B? We use B. Then we get our BCD object by passing this up directly to SVRF object. And CD represents the code, but we still need to get to the actual first opcode, which is not the same thing, because the CD is more than just code. It's also the hot lists and all kinds of funny things. So then this root assignment actually gives us the first lead sub opcode in the CD. And since it's a unary operation, we get to the next one, to its kid, basically, to its child, by using the first method in the B object. So by doing this root first, we are getting to the line sequence of, which is a list opcode, right? So we could use another method. We could get the number of children, because the list method has more than one operation beneath it. So the children method gives us the number of those operations, and then we still get the first of them using first, and then every other using sibling. And if we just execute this code directly, then we will get this out, which is basically a pretty faithful representation of what beacon size does. And as a matter of fact, beacon size does something similar under the hood, of course. So again, entry point, sequence of statements, line number, constant value. Okay, but what about constant value? Because beacon size actually gave us that it was 2. And if you are to implement stuff like DBIx Perlish, then we would like to know the values of things. So again, it's not particularly difficult, because the operation, this $op of the unary, was it unary? No, of the SVOp called const. Every SVOp has the SV method or SV data field in the prolgats, which gives you this scalar value reference, or in case of the B module, a shadow B object for the scalar value, which we could basically just convert back to the prol data. So object to SV reference will give us a reference to that constant, and then we dereference it, and we get 2 back. Right? So what about variables? If we return a variable as opposed to return a constant, like my x 42, and I already mentioned a couple of times that then we're talking about paths. So instead of the SVOp, where we could use the OpSV method, now we have to find another way of finding it. And the pathsv is kept on a hot list, which will basically in general change on each invocation of the subroutine, because handles the closures and all the values as they change and so on. Anyway, so our CD, our code value, our sub actually has a method by which we could get to the pod list. We could get basically everything within the pod list. And at the operation itself of the pod list, we have a target which gives us basically a slope in the pod list, saying, okay, number 3 will hold variable $x. So then we get the $v, which will be again the BSV shadow of the real thing, and we convert it back to the reference and print it out. And given those 3 things, basically, the ability of getting to the constant, the ability of getting to the variables, and the ability to parse the whole tree, you already see how this progress thing will be implemented, right? Or anything. So we would, of course, do something more complicated. Again, a very simple subroutine which returns not just a variable, but it does some dereferencing. It does 2 levels of heavy dereferencing and 1 level of array dereferencing. And again, with our little ordinary recognition, you can see that there is no principal difference here. I actually skipped the leave sub stuff so that not to clutter the screen. But at the beginning here we have that, okay, it's a binary operation to get the array element. And that binary operation has 2 hits. One is the actual array, somewhere here, and another one is the indexing to that array, which is a constant 0, right? So we start from the right. Then, okay, then we have the reference into array, and after that, we have the hash element, which is almost the same as an array element. Again, it's a binary operation, and we have 2 arguments. One of them is the key here, Perl, and another one is the hash. And then we just go down, down, down until we find the end, in which case it's just a class V, and we already know how to get to the class. So we could basically unroll arbitrary complex data structure by hand. So, unfortunately, there are, of course, some complications. One of the biggest ones is related to the fact that Perl compiled with thread support stores stuff quite differently. So basically, all the things I was showing you about how to get to the constant, how to get to the variable is not true with thread Perl. It is done in a different way. In particular, if you remember when we started to extract the value of the constant, then for the threaded Perl, it is also kept not in the operation itself, but in the body history. For whatever reason, I don't know. Someone?
Do you want to know?
Yes.
Do you want to know? Because the op tree is shared between threads. Variables such as scalars are in individual threads. When you create a new thread,
But it's a constant.
yeah, it's constant, but it's stored as a scalar variable at SV. SVs belong to one thread and are not allowed to be looked at by another thread. So there has to be an indirection to the pad, because the pad is cloned, so that when you start a new thread, you've now got 2 copies of the pad